just recently published it. So if we look at Databricks, again, I'm getting old, can't find things so easily with my eyesight, but we can see that's Databricks local file system. A lot of stuff in here I'll be talking about tonight, so it's a good intro into this, okay? If you need to write anything down or take a screenshot, this is the only thing you really need to know. This is my community repo. I have about 30 presentations out there. Everything that we're going to go over tonight is in this repo. So if you go up to the top, it has the abstract. It has also the PowerPoint presentation. We're going to be talking about the Microsoft AdventureWorks data warehouse, and we have the actual CSV files to build it. So we're going to show how we can build a data lake with CSV files, okay? Not my favorite file format, and we'll talk why later on in the presentation. Also, there's code samples, right? So we have 4 different code samples. If you haven't worked in big data, anything with extension of PY is a Python notebook. Anything that with extension of IPYNB is a Jupyter notebook, okay? And Databricks uses Jupyter notebooks, and we'll get into that. Last but not least, anything with an extension of DBC is a Databricks compressed library, okay? So you can bring that back right into Databricks and get it working just like I'm showing you tonight. Let me close this out. I was talking to someone, I just posted it. This is one of the presentations we're going to get into, and this is Azure. So if you haven't done anything in Azure, you're going to learn a lot tonight. If you have, then hopefully this is old hat and we'll get into it. So let's bring up the presentation and we'll start it off. And are you seeing the right view, Mr. Paul, or should I change it? Sometimes it doesn't go into the right view.
Oh, I can see.
Do you see the preview, unfortunately? Yeah, let me
Um,
see. Hide presenter view, so let's do that.
no, I actually don't see the preview. I see your one in the presentation mode.
Okay, so you see it right
Yeah,
here? Awesome.
yeah.
So again, real quick, transition your T-SQL skills to Spark. That's what we're going to talk about tonight. And I work for a company called Insight Digital Innovations. I've been there 3 years, and I'm senior data architect. If you need to get in contact with me, if you have any question or something like that, usually I'll answer you unless I'm extremely busy, and that's my email. So the purpose, many companies are moving their workloads from on-premise operational data sources like ODS, right? It was a data warehouse, to in-cloud data lakes, okay? And to do processing on these in-cloud data lakes, a lot of people are choosing Spark, okay? And so this is a key player in the transition. So as a developer, how can I take my existing SQL skills and take advantage of this growing segment of work? I'm a consultant. I work for this company full-time as an employee, but if I was on my own, I would want to be learning some technology that's extremely marketable and everyone's doing work in it, and this is one of these areas. Today, we're going to introduce you to concepts and code that will help you during this transition, so how things work. So before we get into the nitty-gritties of coding, we need to talk about what's Spark, right? We also need to define what a data lake is. How can we work with files and folders? We're going to talk about reading and writing data. Those are all great, but we're working with data at a low level, right? We really can't, we can do stuff on a data frame, but it's not the best way to do it. We're going to also talk about how we take that data frame and post it to a Hive catalog. And once it's in a Hive catalog, we can start using SQL constructs, right? And so there's some SQL constructs that are great for this once it's a temporary table, or if it's created as a table. Then we can use this Spark SQL to just do selects from it, and we can save it back to the data lake by taking that modified SQL, that's the result set, into a data frame and just write out. So we're going to show you how to read, transition the data with SQL, and then write back out to the actual data lake. And that's pretty much what I do all day. The difference is there's different zones, and we'll talk about that too. So what is Spark? Spark's a unified processing engine that can analyze big data. So it has these components right here. Underneath this, okay, Spark is running a version of Java. Okay. Does anyone know what version of Java Spark uses?
No idea which version it
Okay.
is.
Again, it's tough. So thank you for interrupting and telling me that, because usually in a small group, I'd say, hey, ask a question, no one say it, and then I get some feedback. But it's using something called Scala, okay, Scala. So Spark has probably about 600,000 lines of Scala code, okay? And Scala code is just basically object-oriented Java. So all this stuff's going to run on a Java virtual machine. Okay, that's how it does the divide and conquer. Okay, so instead of having scaling up, which you do in SQL Server, you just throw more power. I want to throw more CPU. I want to throw more memory. I want to throw faster disk, right? To do things in Spark, what you do is you throw more nodes. I give it a more virtual machines. Okay, and so there's two ways to actually read stuff in a data lake. We can use a data frame, and we can manipulate with SQL. And then we can do the same thing. We can write back with the data frame. But Spark is gaining popularity because other things it can do. For instance, it has a graph engine. Okay. So if you had, for instance, a traveling salesperson problem and you wanted to find out the shortest path or the least cost path for traveling from point A to point B, you could do that using graph. A lot of people are doing stuff in IoT, right? Things are streaming into the event hubs, right? I got a temperature gauge in my house. It's telling me what temperature is. It's streaming in, right? Well, guess what? Spark can also write to files using that technology. Last but not least, it does allow for machine learning. The nice thing about it is, again, you don't have to scale up. You can scale out. So let's talk about the Databricks cluster. This is how it scales out, okay? Each Databricks cluster has a single driver. As we can see, there's a JVM, that's a Java virtual machine. So this is a virtual machine here. And then we have another virtual machine here and not virtual. So one driver controls all the work, and each executor has different slots. So if it had two CPUs, then it could actually run two things at the same time, okay? And this is where, okay, partitioning comes into play, okay? So we can see, okay, that we have 8 slots here, right? So if I took a data file and read it in and wrote it out as 10 slots, and then I wanted to reprocess it in the future, with this current cluster design, right, I would have to run it twice, right? Because the first run of the batch would fill up 8 slots, but then I would have 2 files sitting on the end, right? And then when they were all completed, then I'd run the last 2, okay? So processes that are written in Databricks that are really efficient have a good match between the number of task executors and the number of partitions. So we talked about under the hood, everything boils down to a Java virtual machine. How does this work, right? Well, we have data sets are the same thing as data frames, but they're tightly bound to uh, object types. Okay, so for instance, Java, okay, and Scala, which is object-oriented, use data sets because they're tightly bound. What's less tightly bound is data frames. Okay, so schema at write or read versus database is schema at write. Right, you have to know what the schema is. Right. And last but not least, we have SQL here. But what happens is, regardless of how you write the code, okay, once you say submit, okay, and once you give it an action to do, okay, we'll get into lazy actions versus something that we'll actually call evaluation. It comes and it tries to figure out a logical plan. Okay, so it looks at the Hive catalog. It figures out how it's going to optimize it. It's going to get a physical plan, maybe one or more, and it's kind of like SQL. It actually does a cost model, and it does a selected physical plan. Now, at the low level, okay, of all this code is something called a RDD. So an RDD is a resilient distributed data set. This is something that you cannot, it's immutable, and anything immutable means you can't change it. So when I read from a file and put it into RDD1, that's great. But I can't change RD1. If I want to say that I want to take quantity times price to get total line cost, okay, I can do that as a calculation, but now I have to create RDD2 because you know what? I took what was in one, made some calculations and read it all in and wrote it to 2. So you can never change RDDs, okay? And that's how it works under the hood. Everything is optimized. And what's interesting is that even when you run things, sometimes it will overestimate how many nodes it needs, executors, and then it will suddenly, say, oh yeah, this is running better, or I overestimated, and it'll actually release the actual resources. Okay. So let's review the Databricks service, because I know it's a lot of stuff to talk about, but we want to go over workspaces. Clusters are really important. We want to talk about importing files. We want to talk about the Hive database, okay? We want to talk about notebooks, and we want to talk about jobs, and we also want to read and write files. So we'll look at demo 1, okay? So if you haven't used Azure, I suggest you go out and get $200 of free Azure. Usually they have a free offer, and you can put a credit card down and you don't usually have to pay into, it runs out, or, the end of the month, and you can say, hey, I don't want to renew it. That's fine. So when you spin up a workspace, okay, you can do it through the GUI, say, plus, we can just go over here and say new and then create a resource, right? And then we go ahead and we hit Databricks. It'll ask us some things, the usual stuff. So for instance, Databricks, right? Why is it not just give me Databricks? Let me just do this. Let's go under compute. I don't think it's here. Yeah, it's all different things except for Databricks, right? That's what I'm saying. So it's not here, is it? Kubernetes, nope. It's not really a database. So. Anyways, I'll figure it out later. But in here, it's just not bringing me up the right option. You can find Databricks, right? And once you find Databricks, you can say, hey, what place you want to deploy it. Now, the interesting thing is that I deployed this specifically with a template. And the reason why I did that is because I wanted to break it into 2 resources, okay? Automatically, Databricks creates a resource which is managed by itself, okay? And why does it need to manage a resource by itself? Well, let's take a look. In the past, when you built Spark, okay, and again, I don't know why this is lagging, but in the past, when you built Spark, you would have to go ahead and you would have to deploy virtual machines, and then you would have to install the software for each of the nodes. Then you'd have to make sure that, so that would be all your executors. Then you'd have to make sure that the main node, right, would be a control node. And again, it's the driver versus executors had the software. And then you had to make sure everything was networked, right? The nice thing about Azure Databricks, it does all that for you, okay? So you don't have to worry about it. But in reality, guess what? It manages its own resource group right here. It's called B, I called it, and RI is the Rhode Island SQL Server user group, which I run and used to be a PaaS organization. Again, we're independent now. And we can see we have 3 nodes. Now, why do we have 3 nodes? Well, I'll tell you in a minute. And last but not least, these are typical things that you might have in your Databricks ecosystem, okay? You would have the Databricks service, but guess what? I want to talk to other things in the service. So now what I'm going to probably do is attach a key vault to it. And in the key vault, if we look in there, there'll probably be a password for like the SQL Server. There'll be password or a service count that I can access. Okay, the storage. Okay, so we can see this is a client ID, password, and tenant ID. This is all being a service principal to talk to storage, right? And if I wanted to do something similar for SQL Server, which we have a database, so maybe I would go ahead and from other sources put data into the storage count, manipulate it with Databricks, and then eventually pump it out to maybe a surface area where the end users, maybe they're not familiar with Databricks. They just want to look at it through a database. Then we can do that, okay? So if we go back here, why is it showing me all those virtual machines? Well, see right here, this is our cluster. I created this before the group started because it takes about 10 minutes sometimes when it's brand new to create it. When it's ready created, it takes about 3 to 5 minutes to start up, okay? And what it does is to start up, it has to deploy the machines and actually put the code on and get it working, okay? Now, there's a couple ways you can deploy this, okay? The first way is I can't change this because it's not a dropdown, but I can change this if it was brand new. We'll show you in a minute. There's three modes, right? The standalone mode, and I might not be using the right name. There's standard mode, and this is standard mode. So this is pretty much, there's it's not applying, security restrictions that it could be, okay, the most secure. However, it's assuming that everyone that's using the platform is there and can access the data, okay? There's always advanced options, right? So we can add, for instance, if we wanted to talk to the cluster with JODBC, we just go here, and here's our protocols to use, say, the Power BI connector to talk to Databricks, and that works fine. We just copy this information in, and we'd use something called the Databricks token to get in, okay? If we went to the cluster, we can go back to this and we can create a new cluster, and I'll show you what the other two options are. So again, one of the features that's really outstanding with this is that if you put this to 0, which is a no-no, your cluster is going to stay up all the time. The problem is that you're going to get charged for 3 VMs, okay? And also make sure that if you're using a subscription that's not owned by yourself or the company, right? There's usually a limit on how many standard DS3 V2s you have, okay? So maybe the limit's 10 or 15, 20 in your organization, right? Well, guess what? You spin up, say, something to do a massive workload, and you say, okay, I want a minimum workers of 16, maximum of 32, and you go do that workload. You might actually have failures when this node tries to scale out because there's a limitation. It's called a quota at the Azure level. You might want to look into that, okay? And I've been caught with that before with companies. Now, single node, okay, we can hit confirm, okay? And what the problem with a single node is that you have both the executor, okay, and the host driver on the same node. So the problem with that is now that we're sharing resources. So it's more a threading thing versus before you were actually getting virtual machines. And the last one, which I really want to show you, and it's the most important, is this one, which is high concurrency. Now, on the other two, you can use any type of language to get to it, right? So for instance, if we go back to here and we talked about this ecosystem right here, there's a bunch of languages I didn't show you. So there's Java, there's R, there's Python, right? There's Scala, right? Those all work, right? But when you change back, okay, to high concurrency, okay, it means that you're probably going to want to be applying security and make this really secure, okay, then you're limited to only Python and SQL, okay? Now there's two things. You can enable a credential pass-through, okay? And also is another way in which you can actually do security on tables, okay? So that's all about clusters. Anyone have anything about how, Spark is really related to clusters?
You can ask question, unmute yourself, or you can put in a anything on chat window.
Okay. Well, I'm going to keep on going. I know it's going to be a lot. And so at any time, just throw something out there. I'll pause periodically to make sure you catch up. Okay. So the recent button just allows you to say, hey, did I look at something recently? And I did. I looked at this actual notebook. Okay. And so this is one of the powers of Databricks is A, we don't have to worry about the clusters, and B, we get this great interface that, we can start prototyping it. Now, it's good and bad, okay? I've worked on a project before, which was a huge project. It was a Hadoop project that was trying to go over to Spark, right? And the problem with that is they had thousands of lines of code, and I ended up filling up 199 cells. And I went to the 100 cell and it blew up. So there is some limitations. This is made to be done for fast prototyping, okay? But at the same time, okay, um, you know, you can't write, a million line program here, okay? So that's what it's made. The good thing about it is you can collaborate with other people. So I can look at revision history. So I see that, okay. So now if I go back to the portal, right, and say Deepak was in on this same one, right? I can come back into this and log in, and I'm going to see in here that a little icon's going to show up with the first name of the person who's actually accessing it. It's going to be myself in another window. And you can tell that if someone's in your workspace. And you can share workspaces, okay? So if we go back into here, which we did, we hit the launch to workspace. And so again, this is called the control plane, okay? And this is the front end of Databricks, and the back end is where the virtual machines are, okay? And so this is our control plane, and if we went to recents and we went here, now I'm bringing it up, we're going to see that, hey, there's someone in there. We can know that from this window, Crafty DBA hasn't opened. So you can see that someone else doing it. You can also attach this to GitHub, okay? So we can see all the changes that actually happen to this. And if I wanted to link it to Git, I just click Git and I can link it to Git, and now I can start versioning it, okay? So there's some really nice things you can do in this interface. We can also do plotting, and it also supports different languages. So for instance, when we came in here, right, um, you have to pick the language Python, right? But for instance, say if I want, and usually I tell people not to do this, but we can use something called the magic command, right? Magic commands is for, like, file systems. We're doing FS here, but we can also do another language. Like for instance, if I just want to do Scala, right, I can put Scala there. And I'm not a big Scala guy, but I think maybe var x equals 1 might work, right? And then if we run the cell, it should just say, there you go. I set 1 to X, right? So I wrote some Scala, right? It works. Okay. So that's where we're going to do most of our work, is in a workspace. Now, there's a couple of places where you can do it. You can either do shared work, like for instance, I wrote an article on local storage. I have another one coming up with Delta Lake's article. Also, this talk I have here. So this is shared between other people. Also, you can have stuff that's just private to yourself. So for instance, Dilbert's here. Dilbert might have some work, right? Or Crafty DBA. Oh yeah, guess what? I have something from Databricks documentation I brought on, mount points, okay? So I can see different workspaces here. So that's how it works, okay? Data, what is data? Data is where we take the information that we've posted. It could be on either local storage or remote storage, and we can actually show it as like a table. So we can see that I have fact, which is a fact, right? And then if we look into the fact table, right, we have internet sales. And where do you think that comes from? This comes from Microsoft Sample Database, right, which is the VentureWorks database. And so this should be loading pretty soon. So we can see there's 29 columns. Okay, you still there, Mr. Paul? Just wanted to make sure
Oh,
I didn't
yeah.
hear it.
Yeah,
Okay,
sure.
cool. Okay, it's very quiet, so um, I didn't want to lose you. So anyways, we can see that this is not partitioned. We talked about partitioning. And we can see that these are all the columns, so it's strongly typed, right? And we can actually see the sample data, right, which is based on CSV, okay? So that's how Hive works. We're going to talk about how to create a Hive database and all that fun stuff. I talked about clusters a little, right? There's several types of clusters. There's one that you'll spin up yourself. There might be a job cluster. A job cluster is you wrote a job and you say, hey, I just want to run. When the time runs, it's smart enough to know, hey, you told it how much to run with, and it just goes and uses a job cluster, right? Last but not least, pools. Pools, again, this is all high level. Pools allow you to carve out something. So for instance, the problem is with a job clusters, right? Especially, I start the job cluster and say I wanted to have, um, again, I'm going off swag, but 8 worker nodes. Okay, so that's 8 executors and 1 control node, which would be the driver. So that's 9. Okay, how can I make it go fast? I know there's a 5-minute startup, and I'm running a bunch of jobs between 2 and 4 o'clock in the morning. Well, the problem now is every time I run a job, I incur the startup, right? And then it shuts down. So I'm gonna be wasting time. 4 minutes up, 4 minutes down. It's gonna take forever, right? I'm just gonna waste a lot of time if I had 20 jobs. The way around it's to use pools. Pool says that I'm gonna create something that's gonna tell me how much idle time I have, right? And so I'm telling it that at the most, when there's nothing going on, reduce the cluster to 0. At most, okay, ramp it up to 18, which is twice the configuration I talked to you about, which was 8 executors, okay, and 1 driver. And then you could give it some time, like for instance, this one says that if when I start the first job and say it uses the full clusters, right, then I have 8 nodes. And then guess what? It'll only terminate those nodes after 60 minutes of idle time, okay? So it'll ramp it down to a few and then eventually terminates. So pools are a way to actually get faster starts on your jobs, okay? What we're not going to go over today, and I can just keep on going, is guess what? There's models. So there's a whole section called ML Flow, and basically the same things that come out of machine learning, okay, the standard libraries that are part of Databricks. Okay, it's a little different, but you can probably find your XGBoost and you can find your k-means clustering algorithm and so on. Okay, so I think I gave you a good overview. Let's delve into example. Okay, so I'm going to go back to the shared space, right? And we're going to go into the very first, okay, article, and we're going to walk through it, okay? So the cool thing about this is it uses Markdown, and Markdown allows you, okay, to go ahead and do cool things. And if it eventually shows up, I'll show you. I think I had it. There's command 1. I didn't delete it, did I? Did. Okay, confirm. So I'm going to delete the Scala stuff. So the first thing is this is a local file here. This is my avatar from my webpage. I used to write on the Crafty DBA before I did MS SQL tips. And so that's my avatar. And so I'm saying, hey, this is read and write files. And I can tell it, hey, we're going to show a sample data set directory. So Databricks comes with a ton of sample data sets. Okay, so let's get into how you do that. Sample data sets all. So FS means run a file system command. LS means list it. And if I hit /Databricks datasets, it's smart enough to know that, hey, that's where I want some data, right? And we can see, hey, look, there's a COVID directory. So if I was curious, and we're going to go a little off track here just for a second, I could actually go ahead and say, hey, what's in the COVID directory, right? And we can run this. And we can see that there's a bunch of stuff here, right? There's ERS, hospital beds, and there's US facts, and there's a data set. So there's a lot of stuff in here. And we can go into here, and these with 0 means they're probably the subdirectories, right? And we can see that estimated patient impact and hospital by state. So they got a ton of stuff here. And then for instance, if I go into /COVID-19, maybe it gives us some data sets by day or something like that. So I know COVID's a big thing, so I just want to go into this really quickly. Then we'll move on. So what did I do? So maybe COVID, I thought it was a 19. Let's see. Do this again. Yeah. Okay, didn't like me. So let's try this one more time, and that'll be it. So COVID, okay, and then COVID-19, right? Huh, maybe there's nothing in it. It just doesn't like it for some reason. And then run this. Oops, having some problems with my mouse tonight. Sorry about that, guys. And there you go. So we can see that it's a bunch of data sets, right? And then what does this look like to me? This looks like weekly data sets, right? So now if we go here, it's been a year since we've had this stupid virus around, right? Causing havoc. And now if we go underneath it, we can see, guess what? There is some more data underneath 13th, right? And so there's license, there's a schema, all sources metadata, there's a PDF, and so on. So anyways, I didn't want to talk about COVID, but that's how you do it. There's a ton of data sets. We're going to move on to the next one, okay? So next one is we can also look at, there's different ways to do commands, okay? And so I'm going to flip back to here and do a little more showing to you, and then we're going to show you what's the different commands, okay? So data lake zones, okay? So when you, okay, and again, we're not going to do that tonight because we have to attach to remote storage. It's not that hard, but I'm giving you the foundations, right? How to create a directory, how to copy a directory, and so on. And copy files and so on. What I usually do for a living is this, is we have something called the bronze directory. Okay, and the bronze is basically the raw zone. So anything that's coming in from batch, maybe a incremental load, 1 day of data from like say the patient is coming over, tables coming over, right? Or maybe we're having streaming, right? We have a telemetry from like lab slips coming in, and that's streaming to a directory over here. And what we'll do is we'll use this little symbol here means Databricks Delta. We'll read it up, right? And then maybe we'll put it in a Delta file because Delta files have ACID properties, right? They're able to read, write. You're able to do all the fun stuff like insert, update, and delete. Also, it does time travel. And then once we have the data here, maybe you would want to know all the patients who had COVID, right? So maybe that's another data set we'd do. And that would be the gold. And that would be something that we could either have, that Power BI connector connect directly to Spark to read, or we can put it into a SQL database to read. So basically, this is the data quality zones of a data lake from Databricks.
John, I have a question here. So what's
Sure.
the difference between your data lake and delta lake? Because I work with the data lake, but I'm not
Yep.
sure what is delta lake is.
Delta Lake is a format, and let's see if we get to it. I'm pretty sure it's in here. Hang on. Right there. Let's jump to it and we'll go back. So a Delta Lake is based upon a bunch of Python files. Remember we talked about an RDD is immutable? A
Mhm.
file's immutable, right? Because if you ever worked, okay, with storage, right, you can upload a file, you can download a file, but you really cannot manipulate a file once in S3. You cannot really manipulate a file when it's in, data lake storage. You have to bring it into some compute, read it in memory, and that's what Spark does. But Delta's even better because you know what? Now you have a bunch of Parquet files with logs, and it's telling you, hey, John deleted this record or John updated this record. So now instead of taking that Parquet file, reading it up, maybe deleting a record and writing it down, or maybe deleting one record, inserting a new record and write it back down. So you see that's a lot of work. Not anyone can be using it at the same time. Delta allows you to do ACID, right? So now you have atomic, consistent, independent, and durable. You have schema enforcement. Time travel means I could go back to when that change was, say, hey, I want to go back one version. What did it look like, my data, before that change happened, right? It allows for multiple readers and writers in its open source format. So that's the difference, is Delta is much better than just like Parquet, JSON, and what else? CSV, delimited.
It's a format we're talking. Okay, it's
Yep,
fine.
we'll get into it and I'll show you how it is. So the biggest thing is with a data lake, the main thing is the data dictionary. And a lot of times, like I'm working for this current company, and what we do is when we pump the data in through ADF into the data lake, and then we run Delta programs to do stuff on it, we have a table called data dictionary. And what it does, it tells me the directory. So like maybe it's a raw file, and I'm working with hospital days, so Epic, maybe Clarity, maybe it's access dot provider, right? And so that would be a subdirectory. And then maybe I would go ahead and put the month and a year, so year, month. So I would subdivide it if someone's looking for it, and then I put an incremental file in there, right? So it's very important. See, as you can see, when I gave you that hey, I'm dividing it by subfolders so I can find by time. I can also find by use case, and I can also know what's on the file. Okay. Various file formats. So this is why I told you CSV, I hate it, right? CSV, okay, can lead to data quality issues. For instance, someone goes ahead and puts an extra comma in it or something, or sends you a bad file, try it in a file share, and you read it up, right? It's going to break, okay? Also, it doesn't allow compression. And guess what? I have to guess at the type, right? The way Excel works with CSV, it reads the first 200 or 500 lines, right? And if I had social security number and most of them were 000, right? And at line 600, say I did 00 hyphen 11 hyphen, 2222. That's a social security number, right? But now I switched it. I thought it was a numeric, and now it's an alphanumeric. It's going to break. Okay. The good thing about the Apache Parquet format, and it's the foundation of Delta, okay, it's strongly typed. It's a binary. You know what the column names and types are. So like JSON, say if you had JSON, and you had to put a floating point there, well, guess what? You have to round it, right? So there might be loss of precision, right? If you're using Parquet, the chances of having loss of precision, if the two, data types that have the same scale and precision, is probably a lot less. Okay. Also allows for compression and it can be splittable. Okay. So one of the things when you talk about these, and again, we're not going to get into this tonight, but I'm going to show you some examples how to play around with files, is load patterns, right? So typically very small to medium sized files, we can just do a full load it, right? So we can say, hey, you know what, bring the full file into the RAR zone. I like using Delta in the refine zone because now I can put it behind Hive and it automatically understands any changes quickly. I don't have to manually run a system command to update Hive. Then guess what? That's great. I can do that. It's a very small amount of data. I can rewrite it. It's not a big deal. But when you start getting to medium-sized data, right, we want to do dailies, incrementals, maybe by date, okay, or maybe by some range of numbers. Hopefully you know how much you're getting in or something like that. Um, the largest data sets, you definitely want to do incrementals and also make sure you have a good partitioning scheme. We already talked about the delta, and we'll show you. I don't know if I'd show an example, but after Mr. Paul, I'll show exactly. I have some examples of it. This is why I wanted to get to Databricks file system. So out of the box, the Databricks has a local file system. That's what we're going to use tonight. That way, I don't have to talk about remote storage. It's not that hard to use, but you have to talk about credentials and pulling from a Key Vault, and I only have an hour to do this, right? But we're going to do everything locally. I already showed you some data sets that come ready local on the storage, okay? And there's many different ways to do it. So FS means file system. And when we use the file system command, we can do like anything in Unix, like ls means list. We can do rm remove, right? We can do mkdir for make directory, cp for copy, right? See where I'm going with this? The same commands are done in Python. So dbutils is the actual library, .fs is file system, .ls, and then here we don't have to actually put the hot mount. Now they call this a hot mount. So some commands will actually need to have the hot mount prefix it. Also, all these commands that are working with file system are always executed okay at the driver. So it's very important to know that because when dealing with large files, you can crash things if you don't be careful, okay? So this is doing import OS, and it's listing the directory from Python, right? And this is doing sh, so this is a shell command versus a file system command. And again, it looks the same, but the only difference is we're prefixing it with the hot mount, okay? And so we're going to get into this right now, which is Spark read write files. We're going to talk about that. We're also going to do some manipulation, okay? So PySpark is a API. We talked about, the ability to read into a data frame. So Spark.read reads, Spark.write writes. Nothing big or more magical than that. And it's we're going to get right into it. So let's go back to the examples we were playing with. And minimize this. Go back in. So at this time, we have this data set. We saw a bunch of data sets here, okay? Now, what we can also do is we can say, we can do the same thing, do sh on the same data set, right? So we're now doing a shell command, and we'll get the same thing, but the output's a little different, right? We have this, right? Also, this one, we can actually do charting, right? If we want to do a bar chart, which doesn't make any sense, right? We still can do it, right? So we can go back and just do, back to this and say, hey, that's stupid. But when it comes out in a frame, then we can play with it. When it comes out straight text, we can't do any quick analysis, okay? So we're going to look at some power plant data. There's a data set called power plant. And so if we run ls and run this, okay? And the cool thing about notebooks, okay, is it keeps track of what happened last. So if we go down here, we can see I ran this last in December when I talked to a user group. So it's been sitting here for a while, but and I had a cluster, and guess what? The cluster name was different, right? Right. My cluster right now is ABD, which is Azure Databricks Training, but I called it sample cluster. Okay, maybe I was writing an article. Okay. Now, what we can also do is we can use the cat command. And there's interesting thing. There's some hidden commands out there because this code is inherited. Okay, from Python, IPython. Okay, that's Jupyter Notebooks, IPYN Notebooks. It's IPython, Interactive Python Notebooks. We can do something called the bash command, which is the same thing as doing sh, right? And so it's saying, hey, run a bash shell. I want to cat the actual sheet one. So now if we run this, and I'll run it right now, we can actually see what's inside the data file. It's a tab delimited file, okay? And we have a bunch of data points, right? We can also go ahead and use, I'm trying to show you all the examples of stuff we've seen. We can also write a program, right? This program says, hey, I know there's a README file out there. Open the file, join quote with every other line of the file, and then print the line. So if we run this, okay, and we hit run, okay, we're suddenly going to get, the wiki about the actual data file. Now, what I did ahead of time is I went ahead and I went to this and actually copied out, okay, a here document. So this is valid Python code, but I wanted to know, hey, what does T mean? Because we have this up here, right? I don't know what T is. It's way up here. And it's really AT, and I don't know what V is, but we can see T is temperature, uh, P is the ambient pressure, and so on, okay? So let's actually read this into a data frame. That's where I do most of my work before I get to Spark SQL. I just read it into a data frame, okay? So now what we're going to do is, the beauty about Spark SQL is you can just give it a whole directory. And if you do, give me this directory star.txt or star.tsv, it's going to read everything. Now, I did open parentheses, close parentheses, because this allows me to do formatting like this. If you don't like that, you have to do a continuation character end. Okay. The main thing is I'm going to set my data frame for the plant data, okay, the power plant data, equal to reading from Spark, right? The format CSV, right? Which it is because there's no TSV format, but I'm going to change the delimiter. There is a header, so I don't want it the header. I'm saying use the standard quotes. Now, this is really, really important, okay? When you go ahead and you load something, okay, there's two ways to do it. You can infer the schema or supply a schema, okay? Here we're doing demos. It's really easy. It's caked, right? We convert a schema. In production, you want to pass it a schema. The reason why, it's going to have to do the read up, right? Some data before it guess at what it is, and it could be wrong. More than likely, it's going to be right, but it's going to slow your processing down, okay? So we're going to load it from the source path, and we're going to repartition it. Means when we're done, by default, it's going to come in as 200 partitions. We're going to have only 2. And if I hit the display, it's actually going to give us, again, a grid that we can play with. Now, interesting thing, when it runs like this, we can actually go take a look at the job. And so if we're interested, we can actually view it, okay? And then we can start getting into the actual executors. We can see what happened on the executors, and we can see all the Java code. I usually don't do this unless I have to debug something, something's crashing or something weird's going on. But we could go into like stand it out, and we can see, okay, exactly, what's loading. This is garbage collection and so on. There's some failures here, but this is the startup, right? And so we can exit this and so on. So interesting thing, each stage, remember I told you the executions might be in stages, and sometimes it depends on the executors. So we can see that stage 101, it actually used one node to do this because it was such a light load, okay? We can also look at this one. We can see if there's anything to the right. There's no output here. We can see that it took 6 seconds. That's the input. How many kilobytes? Not big data. Where else we can see? Stages. We can look at the stages that ran through. There's also a cyclic graph that you can look at. I don't know where that is. I always forget where. Maybe it's back here. But anyways, there's a lot here. Here's your DAG visual. So what it's going to do is scan text, okay? And then after it does a scan text, it's going to do some code gen, okay? And that's how it executed internally. So I'm still trying to become a guru at this. I mean, I just write it, and if it finishes in a timely manner, then I'm happy. If the client's happy, right? And then what we can do is we can, like I said, we could do plot maybe aligned, right? We could do V temperature over pressure, right? So if we do a scatter, right? And then why is it doing this way? We can do plot options. Maybe it's just picking the wrong things, right? And then we want to do temperature, right? Oh, it's too many things, that's why. So we want to do temperature. Oops, come on. And we want to do pressure. Hit apply. Hit confirm. And there you go. So now it's going to run again, unfortunately. But then the output's going to show it in this scatter plot. Maybe that's your pressure over temperature, and that means something to you, okay? So again, if we don't want it, we go here, we get our data. One of the things we want to talk about is how do we create a data lake? Now, if you're using remote storage, the commands are the same. So we're going to use rm recursive, and what it's going to do, it's actually going to get rid of anything that's there. So let's take a quick peek to see if there's anything there. I'm going to go a little off-road on this and take my four-wheel drive out, and we're going to do %ls, right? And then I'm at fs, and we're going to do ls/ri/sshg, hit run. Now, if you hit the control command with the right or left control and enter, it actually runs it for you. And then I want to do is bronze is our raw directory. And if we go into raw, we can see we have some data in there. Okay. So, So through these exercises, and all I'm going to do is cancel. I'm going to delete this because we don't need to do this, confirm. And we're going to do this. We're going to remove it. Then we're going to make the directories again. So this will wipe everything out that I just did. Okay, and it came back true, that's great. And then now if we go ahead and we say, hey, look at bronze cell, okay, there's nothing in the bronze. So now what we can do is this previous one, this data frame's here, right? We can refer to this anything, and it has properties, like we could do different functions against it, right? Spark SQL functions, right? It's just like pandas, right? So this one, we're going to say print the number of data points. I want to know how many rows we have. Okay, so it's going to run a little job, and guess what? We have 47,840 rows. I can also say, hey, guess what? I want to take that and write it to a single file now, Parquet, right? Overwrite and save it to a destination path, okay? And we run the cell. Okay, and now I can list the directory contents of the directory, right? So I'm going to go into Power Plant and look at it. Oh, okay, that's interesting. Why is this happening? Can anyone explain why there's two Parquet files? There's a success flag, there's a committed and started flag there.
This snappy file created, right?
Snappy's there, but let's go back to what we defined. When we wrote, we said repartition two. So we said, hey, write two files, right? Second thing is when you work with Spark, even though you give it like this right here, a directory, it's not going to write out a single file. So if you want a single file, then what you're going to have to do is you're going to have to say repartition one and find the file that starts with part star dot whatever you're doing, Parquet, rename it and move it out, and then delete everything. So this is just overhead of Spark actually writing in parallel. Okay, so it has the success, it has a committed and started, and it creates your two output files. Okay. The interesting thing is these are all the out-of-the-box formats that are supported, right? So file formats, Avro. CSV we talked about. JSON's almost like CSV. It's not a big deal. It just you have to give it schemas. Parquet we used tonight. Text. We did open text, but we can do that in JB ODBC, so we can talk to a SQL database, okay? Any questions?
Not so far.
Okay. I know it's a lot. We're going to get more. This is to be a crash course, okay? And this is for you to actually go back and look at this after we're done tonight. And if you have any questions, please ask me. There's plenty of resources out there too. So processing files. So we talked about weak files take more processing because you have to infer a schema, okay? We can also, which I didn't show tonight, you can also handle corrupt records. So if there was corrupt records, you could have it specify, hey, when there's corrupt records, then write to here, okay? PySpark. So we can do some things like create and drop statements for databases, tables, and views that are supported by the Hive catalog. We also have something called Spark.SQL. This allows the program to execute dynamic Spark, for instance, select statements. And what it is that if we say df equals Spark.SQL and give it a statement that runs against a Hive, then guess what? Suddenly now we have a data frame. We can also use the magic command %SQL to execute SQL in place. And last but not least, what we can do is we can take any data frame, okay, and say df create or replace temporary view, and that will convert the data frame into a session level view. Now, a lot of times I do this because I want to read a file up, I want to convert and use it like SQL as a table, And at the very end, I will write the data file out. And guess what? I don't really care about the temporary stuff I did in between. Okay, so example 2 is going to be using a famous data set. It's the New York City cab data. I think it's like 100, is it 80 million or something rows? I forgot how many rows it is. We'll find out. Okay. So here's the thing I didn't show you. When you get into here, and if I just go ahead, hit run, it's not going to work, okay? And the reason why it's not going to work is because we always have to attach to a cluster. So we want to, once we're in here, if you're ever in here and you do an interactive development, you want to always attach to a cluster. You can start it, you can stop it. Sometimes a cluster gets into a weird state and maybe you have to detach and reattach, or you can restart, okay? So that's always a good thing. So if we go into here, we can go and run the command, say cat, and we can see that gives us information about it, okay? We can also run a command that says, hey, Spark SQL show databases, right? And then hit show. So this is what I just showed you. Is this gives me first, okay, a data frame, and then I'm using the show feature, a data frame. We could have also have done, for instance, if we did over here, we could have done, for instance, the display. If we like the column format, you know, the grid, and then DF, and then if we do this, this will give us the grid that we can play with, okay? So we want to create a new database, right? So let's see if this,
John, sorry,
yep.
sorry to interrupt you. It's a very stupid question, probably. So when you say Hive database, is this some way connect with any SQL database, or just completely separate database is called Hive database?
This is when I talk to a database, unless I say a JDBC connection to a database, it's a Hive database. So we're working with, we always in the data lake and Spark, we're always working with files.
Okay.
But a lot of times we don't want to use, like once we load, for instance, I'm working with Epic. Epic has 1,200 tables. Once I have those 1,200 tables, that's in my refined zone. Those tables match the clarity tables. But for my consumers, what I want to do is I want to combine those tables in surprising ways to give them data and data files that they can get to. Now, the way to surface it would be they can talk to Spark through JDBC and actually select from the Hive table. That's one way. Or I can export it to a format that it can read. For instance, if I wrote it back to a data lake, Parquet is readable by, you know, Power BI. Or we can put it in another SQL database like a data mart that just has summarized data and let them work at it there. But again, anytime, a good question though, anytime I work with data, okay, I'm going to be talking about a database that's in Hive, and these are the databases in Hive.
Oh.
Now, if you don't start the cluster, you will not even see these databases. So we have a New York City database here, right? So we're going to recreate that one, right? So to do that, what we're going to do is we're just going to uncomment this command. I hope that answers your question.
Yeah, sure.
Okay, so we're going to uncomment this thing here, and we're going to run this cell, right? And okay, so now it's going to tell me, give me a second. Again, can't be doing everything, so let's just do these. Delete. Delete. Just give me a minute. So one of the things you can do is there's recursive things. I could just got a list and I could have done a piece of Python code that converts the data frame to a list, and I can dynamically create Hive SQL just like we dynamically create SQL Server T-SQL and execute this. Again, I'm going to put a comment on here to improve this demo. I'm going to put everything in New York City, even though it's not New York City, but I'm just going to use that as one catch-all tonight for the rest of the examples. Okay. So at this point, I couldn't delete it because it told me it was not empty. And now once I clear it out, guess what? We go back to data and we no longer have a New York City Hive one. So we can go here, we can go here, but the New York City is no longer available, okay? So now if I want to create it, I comment this back out. I'm gonna put some notes here. Right, dynamic Python to clear database. Okay. And so what we're going to do is we're going to create it. So if we run this, we just ran it. If we go to data And now we have New York City, and it has nothing, okay? No tables. So we can go ahead and take a look at some tables. For instance, I noticed when I was looking, this had some integrity issues. This was reference data, this was trip data, okay? And if I want to show part of a file, say we can use the cat command again, right? So if we run this, we can see that's the cat command. We can see this location, borough, zone, and so on, right? And again, I'm going to let you at your own time, because we're running out of time, run through the rest of these, okay? We had nothing new, right? There's no code here, so I don't know why that is there. This is just, okay, so this is what we're going to do. So no, what I did is I wrote this piece of code, and again, this other code just to play around and remove stuff if we wanted to. And what I want to do is I want to create a sample data lake, right? So what I'm going to do is I'm going to run one, and I'm going to say make a directory under bronze called payment type, and then I'm going to copy over, okay, the CSV type. And then I'm going to make the same thing in the CSV in a refined zone, okay? And then if it's a 2, I'm going to repeat this, but I'm going to do a different one, rate code. And if it's a 3, then I'm going to do another one, which is a lookup over here. And at the end, we should have something that looks like a data lake, right? And this is how you do, coding with Python and using the commands I just showed you. So if we go ahead and run cell, we can see it's done. So now we can put this in as a 2. And now if we run cell, and now if we put this as a 3 in, okay, we run cell, okay. No, I thought it was done. Run cell, no. I guess this one's big. Okay, so that one took 28 seconds, so it must be some serious data there. And run cell. And that's done. So at this point, if we're curious, we could go ahead and look at, for instance, the payment type and see if there's some data there. And I'm not going to go through all these. You can play around, but there is a file there, try it. And then if we go ahead and put this here, we can go ahead and run this here, okay? And so now we have another one, okay? So I happen to have, this would be like an example of a full load, in which the full load that goes into raw zone is the same thing that's in a refined zone, okay? Now what we can do now is we can write some logic. We can say, okay, drop my New York City payment type, right? Then I want to create a table, New York City dot payment type using CSV, okay? Location is silver payment type, taxi payment CSV, options header equals true, and then run it. So if we run this now, this is going to bind, okay, our CSV file as a table. And now we have something called payment type. And now if we go ahead and we run this, okay, we can actually select from payment type. Let's repeat it. We're going to do the same thing for the silver zone for the rate code. So now you can see how I'm building up a data lake. We would have used ETL, could have been Azure Data Factory, or maybe somehow the files get dropped in the raw zone, we move them with Databricks. Both are acceptable, whatever way you want to do your data engineering, right? And last but not least, we want to do the thing for the lookup, right? So we're going to run this piece of code. Okay, and now we can do the lookup. Okay, so let's take a look at this one. The interesting thing is we're going to create the yellow cab data, right? And what we do is we can drop the yellow cab. This time I'm not going to copy it in the data lake. I'm just going to go directly to where it is because I want to show you some bad data, right? And so if we run this particular cell, okay, this might take a little while. Okay, so if we go to our data, New York City, right, we can see that there's a yellow cab. And we can see right here, there's 21 rows, no partitioning. And it's going to take a little while to bring up the sample data because it's going to have to go to a CSV file. So it goes ahead, okay? And there's only 20 rows, okay? So boom. Come back. It's an Azure night tonight. It's a little slow.
So those table, John, is actually built in Hive on top of the CSV file, right? That's what I'm doing. Yeah.
That's a built-in type of a CSV file. I don't suggest this, but okay, it is. This one, did I run this today? 318 is an actual Delta table. So I pulled in a Delta table, okay? The thing I want to show you is that we can format the number of rows. Why is it taking so long to run this, right? Well, if we look at it, there's what, a billion rows here? So this is million, billion. So 1.6 billion rows. That's why it's taking so long. So now we can go ahead and say, hey, look, where the vendor is CMT, limit to 50. So now we can start doing queries just like SQL once it's posted. And we can do data exploration, right? So I showed you how to use SQL. What you can also do is there is some formats that are supported that are compressible for CSV. That's one of the problems with CSV is that A, you have to give it a format. B is it's easily breakable unless you're guaranteed that you wrote the data, right? Hopefully the data is not broken coming in. But you can also do something like this. This one's actually going to do a Spark read, right? But now we're going to do the trip data yellow, and I think this was this yellow cap? Yep. So this is the raw data behind the delta, and they're in ZAZ format, so they're compressed. So now I can run this and read up compressed files too, and a bunch of them, right? Star.za. Okay. So we can see probably it's running, so maybe brought up 4 files, right? 16 more fields. And now if we display it, we can actually see the data come out. Okay. So one of the things we have though is that we might want to look at trip data, right? So trip data is yet another data set. Okay. And remember we talked about how you handle, okay, issues if there's issues. We can say drop malformed, okay, option. And when the data comes in, we just don't drop it. By default, when there's error with the data, it just goes ahead and it will error out, okay? So maybe drop malformed is one way, error out's another, and I think there might be a third one which you just capture it to a file. And again, look at the documentation. I don't do this too often because we usually use Parquet format, and we know it's coming from a relational or strongly structured format, so we're not having any issues. But CSV, a lot of times you have it, right? So you might have issues. Okay, so while this is running, let's see if we can throw some slides together. So we talked about that. We can do some things with data frames too, right? For instance, not only is, okay, Spark SQL the only way to manage data, okay? Or manipulate data, should we say. We can also use a select. We can say select to reduce the number of columns. We can do with column to reformat. We can do a where. We can do expressions, okay? So there's a ton of functions that can be used with data frames, and some of them are related to like pandas, min, max, and so on are all there, right? So the documentation is pretty thick. Wow, this is still working, huh? Well, we can see that when I did LS of some of these, we can see that this is which table is this? Is the question. We can see, look at all the partitions for the Snappy on the Delta Lake. It's pretty big, huh? A lot of partitions. Maybe I didn't give it enough horsepower tonight. It says running command, but I'm surprised it's not showing me. It might be going slow because these are not, remember we talked about I'll see if anyone's paying attention. Where is this getting executed, this command right here? This very make directory and a copy. Where is it getting executed? Is it getting executed at the driver node? Is it executed randomly on one of the executors?
Driver node.
Exactly, and that's why it's taken so long. We probably don't have that much horsepower on the driver node, and so it might take a little while. Let's see if there's anything else interesting. So this one does the same. Yep, go ahead.
So is it also could be like the yield taxi show? There was a 1.2 billion records.
1.6 billion. Yep.
Yeah.
Yeah, and so this one's copying it over, and so it's just taking a little while. We can see it's finally now it did the copy, right? And the second part after the copy is it reads up this as a CZ, right? And then we rename one field, right? It has a space in it, and then we write, maybe it was causing issues with deltas because delta has some issues, like if you don't have names, things named certain ways, then it'll cause issue. Maybe this was blowing it up. And then what we're doing is we're writing it back out as a delta. So this one right here, see this, right? This is writing out the delta, and we can see the stages right here. And so it's running 9 to 25 steps, 8 at a time running. So let's go look at the clusters. I'm curious. I'm going to bring up the other one so we don't mess up this one running. But sometime during execution, right, it will resize the nodes, right? It'll say, hey, I need more work. Go out there, go get me some more clusters. And nope, it's still only running 3 nodes. So surprised, but that's what it's doing. So I'm not going to do all of them. I'm just going to do the very first one when it gets done because they're pretty much, you can see they're repetitive here. And then maybe we'll go down to, you could take a look at this one. As long as in the third article, I'm not referring to anything here, we're fine. So, still running, huh? We can also see when you run this what the actual data frame looks like. So they're all coming in as strings. So another thing, probably because of CSV, we didn't give it a format. And so it just finished. It took 4.5 minutes. So that's too long to do. So we can go ahead and now, once it's in the Silver Lake as Delta, we can, and again, I'm pretty sure, did I say right format Delta? So now it says a Delta file, right? When we did bronze, and which one was this? Just double checking. This was yellow, right? So if we go down to LS Silver Yellow, this should work. So it's the yellow, and maybe it doesn't look me then. What was it that executed then? Was it green? Maybe it was green. Green. Yeah, it was green. Why was I doing yellow? Who knows? So if we execute this one, okay, we can see now there's a ton of files there, right? So we can go ahead now and create the table from here, and this will create a table for us. And now we can go ahead and select from the table, okay? Now, if we didn't want to see everything, we can also use a syntax limit. It's almost like Oracle or Postgres, not SQL Server. It's, we do top, 5, be SQL Server. We can also take a look at the size of this, and this said 25 million, so let's see. And you can see that it took a lot longer to process because it wasn't in Delta format or Parquet files, right? I'm going to skip over this because of time. We can also bring in the 4 hire vehicles. So there's green cab taxi drivers, okay, and yellow. So those are like, unions. And then there's 4 hire vehicles. So we're curious in our analysis, we want to bring them in, okay? So we can run this and we'll bring in this. Why doesn't it like it? Create tables using Delta. Oh, because you know what? Okay, well, maybe we'll go back and do this. It's number 6. Let's see if we can do 6 and then 4 last. While this is running, I'm going to look at sample 3 and see if it's dependent upon this. Okay, shared Python. Okay, I'll let that run in the background. We'll come back to that. We're going to talk about the next thing, which is this one goes over. Okay, yeah. So this goes about the select stuff, right? We talked about how, not only can you do manipulation in SQL, but you can also do it on the data frame too. So you just have to decide which one you like. The syntax can get, quite weldy on the data frame. You can, Spark 3.0 supports a variety of things like CTDs, rollups, windowing functions. So the question is, how would you do that in a data frame? You're just going to have to figure it out. That's why I like staying with the T-SQL, because you can transition the skills over really easy. So if we look, we can see in Databricks datasets is something called Lending Club Statistics. Okay. We can see this is pretty big. And this is the actual information about what it is. So if we do an SH of that, we can see, hey, this is a lending club that was in San Francisco. Okay. So now what we can do is we make 2 directories and we can copy the file over. Okay. It's going to run this. Okay. So now I have the file. Okay. Into the bronze directory. So now I can go ahead and say roar is equal to, and that's bronze, right? Read CSV, notes as CSV with a header. Then what I can do is I can say loans1 equals, and I can select the fields I want, and then I can show it, okay? So that first one is to reduce. If I want to reduce the number of stuff that's coming in, I can do that. And now we have all this data. It shows me 1,000 rows. I mean, if you're curious, you just do a plus statement here. And you can do df.count. And this will give us the total number of rows, right? So what is it? df something else, right? Roar. And so we can see how many rows there are. Okay, so there's only 130,000 rows, and it took us 5 seconds to read. So at this point, what we can do is we can actually do some interesting things. We can go ahead. There is a bunch of functions that you can use with data frames in SQL, but to use them with the data frames, you have to import them. Okay, so I'm going to port everything in. So I'm going to say loans1 is equal to, we're going to try to figure out what is a bad loan, right? So we're going to say loans1 equals the loan status is in, and it's a not, right? Current or fully paid. Then we're going to cast it to a string, so with column. So we're going to add a new column to loans1. Then with column, we're going to create some other things. We're going to create interest rate. And in there's a percent sign. So there's percent signs in here somewhere, right here. See if we can see these. We want to get rid of those, right? So we want to replace them, and then we want to cast those to float. So we're strongly typing stuff now. Then we want to figure out the issue year. So the year of the issue is probably, see these right here, issue year. There's like formatted as month and year. So we want to pull that out, okay? Earliest year. We want to calculate the length in years for the loan, so the issue minus the earliest year. Then the employee length is all messed up. There's a bunch of stuff. So we can use a regex replace, okay? So it does some really complex stuff. And then we can write it out. So see loans.write.parquet. So instead of using SQL, we could do all this in both SQL and data frames, but in this example, we're going to do it in a data frame. And we can see that in this one, we're typecasting less than 1 as a 0 years, and 10 and greater as 10, and then 2 through 9 as the numbers. And what we're doing is we're actually, if we see anything that's weird like this, we do NA, right? We're going to put nothing. While that's running, we're going to multitask. Did this finish? Oh, it's still running, see? So I'm wondering, did the cluster actually decide to spin up more resources? Let's see. So now I'm multitasking. This is kind of like what would be happening, right? We'd be having one job go here and another job go here. And this one's still running, which is good. Okay, so we'll go back to this job. So we can see that we actually done it. Now we want to actually, we wrote this to a final file in a Silver Zone. We want to post that file. So far we talked about Delta files, but we can also post a Parquet file, right? As a Hive table. So we're going to run this cell. Okay. And this is going to create the table in New York City, which we already have the database dot loan club process one. And the problem is that with files like this, right, we might not be able to actually, this might not update right away, right, depending upon what we're doing, right? So this is ones here. Okay, let's see if it comes back. There's also a command called refresh table that will help us. Did we create this as one? I don't know why I have this as two. Okay, that did come back. And then let's see if this works. Okay, so there's no such table, so I don't know why I had this here. Maybe I make it, okay. So what we can do is we can also take that data frame. Another way to do it is we can just create a temporary view, right? This is a temporary view. You will not be able to see it, okay? Unlike everything else in here. So for instance, New York City, we have club process one that's here, but we can't see this temp view, right? But we can actually go ahead and select from it, and it is valid. It'll run. It's in the Spark context. It's in memory somewhere. Okay. Now remember that actual translation we did. We had all this stuff, right? Well, this data frame roar, okay, is the original data frame before we wrote it out, right? Because roar, okay, is roar.count here, but then what we did is we said loans, loan status end, right? And if we look at loans one, where did we sign loans one? Okay. Here's roar, and then we did roar loans one equals the select. So this roar has none of those actual transformations that we applied yet, right? So we're going to do the same process, but I'm going to show you how to do it in SQL, okay? So we just do, we're going to create a SQL statement, and this is a here document, so we can do multiple lines. And now I'm doing the same thing that we did, substring, but casting, okay? We're doing regex replacements, okay? And we're pulling all the fields in. We're also saying we're doing a case statement. If it's current, that's false. If it's fully paid, it's false. Otherwise, it's true from here. Then we're going to create loans too, and we're going to create a Parquet file here, right? So if we run this, this is basically running the same thing we did, but we're writing the second Parquet file out into the Silver Zone, but I'm manipulating it with a temporary view. Okay. And then what I can do is I can drop process 2 and then create the same thing off the Parquet file. Okay. And we can select start from the top 10 from this. We run. And it might take a little while, but I'll eventually come back. Or if it errors out, then we do a refresh. And that's it. So does anyone have any questions? Because I just showed you how to do the same thing. Select a bunch of fields to do some casting complex data transfer. You can do it both using this, which I like doing, because guess what? This looks like T-SQL, right? I'm doing a cast. Maybe this is a function that I don't know about, but everything else looks like T-SQL, right? Except for some, complex replacement function. Everything else looks like T-SQL. Or you can try to figure out how to do it this way.
Yeah, T-SQL like feeling like home,
Exactly.
We used to work with that, right?
Exactly. So that's the whole thing, is that once you get the files in, right, you can do anything with T-SQL, and that's the whole thing about this meeting. The last section is designed to reinforce the facts applicable by SAC. So we'll look at simple and advanced constructs available in SQL. So I hope that the last example doesn't use anything that I'm still loading. I think no, I did last times I loaded those, and next time I'm going to learn a lesson, which is I'm not going to trash them before the talk because it's like, yeah, I'm going to clean everything up. And probably wasn't the best idea. So come on.
And is it okay to? I have one more question here.
Sure.
For example, okay, we're kind of building ETL, like like as you do in a data factory, it's a pipeline. So
Yep.
how actually you gonna schedule it, or how can I even invest it, gonna trigger it, how that happens?
Right here.
Yeah.
Jobs.
Okay.
Great job. So under create job, great question. You know why it's a great question? Because it's something that I could talk about, right? And I know it's a bad question I don't know about, right? But we can in here create a job, right? And so, again, this is untitled, so we can put down test job, and then, select notebook. So now we have to go select the notebook. You see where I'm going with this, right? Say first program. Again, this is all going to be foo, meaning that's junk, but I'm just doing it, right? Then we can pass a parameter. So you can pass, well, I didn't show you, there's something called widgets. And widgets, I want to go really quickly into, I'll show you some code from one of all the articles I do, and it has widgets, which is really important. So I have a process that, let me see if I can find this. Great development data is great. Here we go. Is this it? No, this other one. Space. Back up one more. So this would be under shared. It's the data lake article. Okay, here, full load delta table, maybe. Yes, it is. Okay. We can pass into a program like this widget, so we can define how this works. So for instance, say if I want to copy stuff from the bronze and copy it to the refined, we could pass in the path to the data lake, and we could say, hey, this is the bronze path, this is the data file name, debug is true, I want to print out stuff, give it a partition count when I create it. What's the file schema? Remember I told you you can pass schemas in? Well, you can specify them just like SQL here. And then guess what? We would go ahead and this job I just created, which I'm going to delete now because it's useless, right? But cancel. We would go ahead and we could pass the parameters to the job, right? And so this gets to a point where, now you have something that's a job, it runs a piece of code, and now you can parameterize it. And guess what? You got something that's really a piece of engineering, right? And then you can run it over on the schedule, and now things happen, right?
That's very helpful. Thank you.
Excuse me, John.
Sure.
When you schedule the notebook on, should the cluster be always active, and how do you attach it if it's not always active? Thanks.
Good question. Good question. When we went over clusters, right, there's two types. There's an all-purpose cluster. So this one is called the interactive cluster. When it goes down, I have to hit start, and I can play. Once this cluster is up, its memory is what I'm using to run these notebooks interactively, okay? But the jobs actually come up a job cluster. And what happens is when we define this job here, let me do this job again. We can go ahead and we can tell it the cluster right here, say. And so say I wanted to, see it's defined the cluster, say I wanted to, this has 8 workers, right? So it'll stop with 8 workers. So when it runs that job, it's gonna first spin up the 8 workers, then it's gonna run the job. Now, if we use it off a pull, then guess what? If we run 2 jobs in a row, guess what? The first job sets up these resources. The second one will hopefully within 120 minutes, it won't be shut down from the pool. It'll use resources that are already there. But that's how you get your jobs to run faster. It's by using pulls. Does that answer your question?
I think yes, but just to clarify, so the job clusters are always active, do you mean? Thanks.
Nope. Clusters that you define here will be always active, okay? If you set the timeout here, okay? I have to stop this to actually set it to 0. So if you set to 0, it means keep it always on, and this will always be on. Job clusters, okay, job clusters get spun up when the job runs, okay? But that can be defined couple different ways. You could say just run it at this. And if I run it like this, it's going to create a cluster. You're going to incur the 5 minutes of startup. When it's done, it's going to shut everything down and you're done. Now, if you had two jobs you want to run, one would be 5 minutes up, then it shut down. 5 minutes up, shut down. You see, it's very wasteful, okay? If you use a pool, there's a setting on a pool, okay, that tells you how many minutes to wait before you release the resources, okay? So if I ran two jobs, say one at 8 o'clock and one at 7, we ran the 7 o'clock one, and I said in the pool, don't release the resources until 90 minutes. When the second job goes to run, it doesn't incur that startup cost because I can tell it, hey, leave 8 workers sitting out there. And the workers will be ready to just take the job and it'll start in seconds, not 5 minutes, okay? So that's how you make your jobs go faster.
Thank you.
You're welcome. Okay, so we're gonna go back here, delete this one, delete, and we're going on the last demo, which is exploring the lending club data. I don't know if I've totally finished this, but we'll see. And while this is going, we'll go back. Wow, this finished, right? So finally finished. So now we can go here, and I'm multitasking still on this one. That's still taking a long time to run. I thought I just did this. Let's see. Which one did I run? Oh, I did 6. Wow, it took that long for 6. That's incredible. Okay, let me run 6 first, and then I'll run 5, and maybe I'll have enough data to do a demo. Hopefully I'm not using any of this. Don't remember what I wrote. That's the problem. So this is the one we just loaded, which was the for hire. The problem that this one's taken so long is because, now, did you realize that this one says drop table and then create a SQL, and then we select it, and let's see how fast it runs. And this is 260 million rows, so you can see right here. So not as big as 1.6 billion, but still pretty sizable. And you can see that Spark has some interesting functions, like format number. It's another function you can use, and you can give it, it's just like some type of decimal, like the string feature that you have in SQL, str. And there you go. So that one's done. So let me run the very last one. Maybe this will be done by time I do this. At least this will be set for my next demo whenever I do it. So this is 5. I'm going to run job 5. Okay, and then let's go over here. So we're going to explore some lending club data. We're going to do a little more of this. So we're going to show the tables again, so we can run this and we can see what we've done. And again, when you don't have it, be careful. When I just did it, I know I have one cluster, it does it. But if you have 2 clusters and maybe you don't have access to a cluster, they can restrict that. Then this wouldn't work, but it just chose one, right? And so we can refresh to, I don't know why I have this in here, but it's asking me to do that. Now, if I go ahead and limit 10, which we talked about, you'll show the topmost 10 rows, right? So for instance, say we wanted to do some interesting stuff, like we wanted to get the address state, the bad loan, is it a bad loan or not bad loan? We want to get the number of loans, and we want to know the amount average per state, right? So what we can do is we can basically I live in the Northeast, which is Rhode Island, Connecticut, Massachusetts, New Hampshire, Vermont, and Maine. We're going to say, hey, the loan amount is greater than 0 because we want something there. And this one is actually a plot, right? So now if we go ahead and hit refresh, how do I do this without messing this all up? Do I just hit refresh? Fine. Zoom, now out. I can hit run, but I hope it's not going to kill the plot. We'll see. Hopefully it doesn't. Now I'll have to draw it again. And again, we don't have enough time to show you everything tonight, but basically what I'm doing is I'm doing bad and good loans. And what I do is for each one, I have the state, I have the number of bad loans and the amount, right? So I'm plotting the amount, okay, here, okay, versus whether or not it's a bad loan, okay? So these are good loans and amount, and these are bad loans and amount. We can also do Windowing functions, okay? So, I don't know, yeah, farther down I'm doing it. So for instance, say if we want an address state and we want to say if anything's less than 50, right, then it's probably 2000 plus, otherwise it's probably 1900 greater, okay? Because we know that most of the loans are relatively new, right? So what we want to do, this will take us, and this will give us the loan years, right? Because some are 1984, right? And so on, right? And now I did this, but I want to use this data in something else, right? I can use a CTE, so I can do with CTE as, we already did this. And now I can do partitioning, okay? So I can actually get a run amount, right? So for instance, the loan, okay, which again, if you look at this, this is address date and then loan amount, and I can get the loan amount, and then I can do a running total. So now I'm running this with a running total. I'm going to do row number first, and then I'm going to have sum over and then run amount. So now if we look over here, we can see in Connecticut, first loan was 3,500, second one is 8,000, right? So we got 11,500. Then you add 6,300, we got 17,800, and so on. So we're doing a running total. So hopefully I showed you, again, I don't have enough time to show you everything in SQL, but I showed you how you can do CTEs, you can do windowing functions, you can do complex aggregates, you can do graphing. So pretty much everything's available out there for you. And, you know, just go look at the documentation online. I think you're going to find, though, let me go over the summary page and we can wrap it up, and I'll show you a couple of references. So the modern data platform, which all of us are working nowadays, is pretty much centered around having a spoken hub designed, right? So you spoke is either, some people still using ODSs, right? Operational data store, and it's a SQL, maybe using like a data warehouse like Snowflake, Synapse, right? Maybe Redshift, or maybe using a data lake. So maybe using S3, or maybe using, you know, data lake storage. But regardless, the nice thing about a spoken hub design is that you can have producers come and go, okay? But as long as the format is in some type of standard format or pseudo standard, then you can keep track of data over year, right? And you can also, it can either be pushed or pulled into the data lake. So for instance, pushed into the data lake could be something like streaming, right? You, pulling might be streaming. I mean, pushing might be just a batch job, right? And processing can be done on a subset to allow for investigational queries. So we showed that, right? Data science models. We didn't talk about anything about data science, but we could do predictive models, right? And then say, hey, you know what? We marked this as a bad loan, right? And so send that to maybe, you know, someone applied for a loan, and the next day, you know, the person could get an email saying it's bad loans, right? And the following data can be available for customers for analytic reports, right? So the most important thing about deploying objects is naming conventions. I see a lot of people in these companies don't use standards or naming conventions. So, you know, the data lake is not standardly named, the components are not standardly named, they're not doing code reviews, and therefore, you know, it can become quite a mess. So I think going back to basics on this, even though we're using some cool new technology, basics are really important, right? So both Azure Databricks and Azure Synapse support Apache Spark. So, you know, these skills I showed you, yeah, some of them are really tied to specifically Databricks, like maybe %bash, but guess what? That Spark.read, that's everywhere. If you use Spark.read, it'll work on, you know, Synapse, it'll work in Databricks, right? And, you know, if you know Python, Spark, and SQL, then your future is bright, okay? So, I just want to thank you for your time tonight. There's some references you can take a look at. This is an article I wrote, and those are the references. And the main thing out of, like I said, tonight's talk is to just jot down my GitHub reference. Let me see if I can find that again, and you should be good to go. Does anyone have any questions?
John, all the exercise file, you have everything under your Git.
Yep,
Plus,
these are all my articles. I mean, my talks I've done in the were passed, and guess what? This is right here. So that whole presentation I gave you, the abstracts here, some data files. I've used these before. I didn't use them in tonight's talk, but you can play around them if you want. But the code examples, 1, 2, 3, and 4, they're right here.
Okay. Yeah. Please, send this link and PPT.
I will go ahead and send it to you right now in the chat.
Okay.
You can go for it.
Okay. Sure. That would be.
Again, just going once again, anyone have any questions? I mean, thanks again for having me. Hopefully you learned something new tonight. And yeah, I know it's a lot to take in all at once, but get a Python book. You already know Spark, and you've got the basics.
Oh, this is awesome, John. There's so much to learn. Actually, you went through really like a lot of stuff. Now, anyone would like to learn more, need to go more deeper into it. I learned a lot, and so
Definitely. Okay. Well, let's wrap it up. Thank you, everyone. Stay healthy, and I'll see you until next time. Okay.
Thank you very much.
Before leaving, John, I need
Yes.
your picture. It's a photo shoot session, so
Yep.
I just have to take.
I turned on my camera, so if you want to take a screenshot, go for it.
Could you please take your, this I can see in my screen.
Yep.
The PPT, the one.
Oh, let me stop it. I'll stop this.
Okay.
And there you go.
That's great. That's great. It's for the social, so
Yep.
I think it's fine with you, right?
As long as I don't find it all over the internet, we're all set.
Exactly. Yeah, we're good. Thank you.
Excellent. Hey, thank you everyone again. Stay safe. Until next time. Cheers.
Yeah.
Thanks
Thank
again.
you, John.
Take care. Bye-bye.
Thank you, everyone, for joining today. It is great.
You're
Thank you.
welcome. Bye.
Bye-bye.